World here. It's January 13th, 2020. We'll come at you here with a video. But yeah, this is going to be a short one, so I'm just going to jump into it. This is over here at Seeds. Now, if you guys remember right, we weren't able to get any data for like a week. Okay, now you see these boxes here? See how they're purple? If you guys ever go over here, you're going to see that if you haven't looked at that link, it'll be gray. Okay, or it will be blue. If you've already seen it and looked at it, it turns purple. The gray means that there is no data for that day yet. Okay, and that, one day, whatever, we can sit here and talk about that all day long. But there was like a week or so there we didn't get any data. Now, they did go back and they dumped it all in there, but you always have to question what's going on there. What I find strange is typically like right around midnight, 1 o'clock Eastern time, which would be, I guess, 4:30, 5:30 UTC. Usually this box here will turn blue. Okay, and even if there's no like data for it, you can click on it and it just won't give you any captures, but it always turns blue. Well, it didn't do that. Now, I didn't do it on that one or Stereo A. So, all that doesn't really mean a whole lot unless you factor this in. Okay, this is the last. I always do this. I look at the last capture that it gave us. Now, we've been talking about, our object and stuff that does it with the CME and stuff. But this right here is what we're looking at. This is from Soho. This is out in front of the sun, out in front of us looking at the sun. And what you're going to see is, see the timestamp, it says 5:36. It stops. It doesn't give us anything past 10. So watch. I'll just go ahead and start it. Yeah, sometimes it does that, sorry. Now, if you watch it, it's going to go to 10 and it flips back over. Okay, so there is no data after 10 on the 12th up till now. So, whatever, sometimes you get missing data, right? Well, there's the start of a CME. Okay, whenever you see that, that is number one, the tool even picks it up. Okay, that's what that tool's for. See the red and blue lines? It picked up a CME, at least the start of one. But after that, we get no data. They cut it. So, you take that for what it's worth. But I wanted to show you guys that. And as soon as more data gets dumped in, we'll take a look at this CME and try to see if it's even coming at us, whatever it's going to do. It doesn't look to be coming at us because it does look like it's going at an angle away from us. But, you can't confirm any of that until you get the data in. So, yeah. Okay, guys, this is an animation that Scott has put together. Just trying to give you guys a better visual of what we're talking about with this object orbiting the sun and what it's actually doing. And this is probably the best animated part of this that I've seen on this particular subject with the 28-day orbit. Yeah, it actually shows it really, really well. He did a really good job with this software and stuff. So check this out. I'm going to push play. And you're going to see our object orbiting the sun, but what he's depicted here is it's showing the elliptical orientation of this orbit. In other words, it's slanted. Plus, you're going to see that when this object comes around in certain, when it's closest to the sun, you're going to see it induce a CME on the sun. But it's not only doing that, guys. We've been saying this for a minute. It's almost like it's pulling the plasma from the sun. Not just causing the sun to react, but actually kind of pulling some of that. So watch this. Excuse me. See how it's got a very steep angle? That's what we're talking about there. Okay. Now, do you see what happened right there on the end of that? Okay. And this is going to go through a minute. There's a CME. Boom. What's it do? It goes on off into space. Okay. That's exactly what we're seeing on our tools. Okay, and honestly, right here, guys, I mean, this is actually a really good representation of, is this possible for something to orbit our sun in such a highly elliptical, at a very high rate of speed? 28 days, yes. Admittedly, that is fast, and we've been saying that since the beginning. But also, we've seen articles and stuff from some of the satellites that have caught star systems outside of our own that are bigger than ours, the two stars that were doing this, and they were traveling even at a faster speed. We're talking an orbit of like 11 days. All right? Stars that are 3 or 4 times our size. And they're orbiting each other and they're whipping around every 11 days. So this is possible. But I just thought this was a great representation, animation of this actually pulling stuff from the sun. Look at that. And this gives you a really, really good idea of what the plane of the orbit is. Okay, now if you put this into relationship to us, we would be kind of like here. That's kind of the plane we would be on. So you see how that works right there, right? So, you know, I really wanted to show you guys that and just kind of give you guys a better idea. He spent some time on this and it paid off. So there you go. I'll be using this probably constantly because, you know, we always get questions on what this thing actually looks like. So anyway, hold on one second. I got some Schumann stuff I want to show you guys. All right, guys, this is the Schumann from the other day that I showed you guys. You know, I've been talking about maybe the possibility of more than one base frequency, and this kind of shows it pretty good. You see how we're getting a constant vibration at that frequency right there at that hertz level. You know, the 7.83 should be there. That's our base frequency right there. Okay, but anything that's staying consistent outside of that shouldn't typically be there. Because you go back a few years and you wouldn't see that, at least to that intensity. Now, but what I want to show you guys is, you guys remember this, right? Our striped thing here that we're looking at. Okay, now I want to point something out here. Okay, first off, our signature, the code that we talked about here for a while, is still there. Okay, and it does seem to be migrating towards our base frequency. And again, I've tried to put emails to these guys and let them tell me it's a tool flaw. You know, I seriously, I would probably accept that because it very much could be. But they haven't responded. I don't know what else to do with that. But what I want to point out is you got this striped spike, right? Well, the ones right after that aren't spiked. So in my mind, something that's happening that close to that isn't showing similar signature is telling me that this isn't a tool issue. Okay, this right here, because it went away and really close to it. So we start looking downstream here and it's not doing it down there either, right? Well, let me show you the current one that I just looked at. Okay, so to give you reference here, this is back on the 10th. Okay, when we first seen this. Well, yeah, it was on the 10th. Okay, and again, sorry about that. Here's the most recent. We are now to the 13th. Now, as you can see, it isn't quite doing it right there. It's definitely not as visible, but you can still see. This is where I'm having, why I don't think it's a tool issue, because you're seeing it very, very lightly on here. Okay? It seems as though we had a vibration change here somewhere in a massive level. And this is just me theorizing, just throwing this out there, because I really don't know what this is. And it's like it ramps up. It starts off a little slow, and then the intensity and the longevity of it increases. Okay? So we start looking at these other little spikes. And if you look real close, you can actually kind of see them there. Alright? But they're not there on this part right here where it's white. But they were in that previous capture I just showed you. Now, sorry I jumped around there real fast. This is what we got right now. And again, guys, I have to say, I've never seen this before. This is extremely strange. And frankly, it's kind of concerning. Because this isn't... I don't see this being a tool flaw either. Number one, because it isn't just, you know, a little line going across it. This is like, even at an angle, you see this? Like it's, that frequency would have to change at a, you know, over time at a sloped manner. Like a line, like the graphs that we look at, say we got 0 and 100 or whatever, and we get one that's at 10, so the line goes there. Then we get one that's 3, goes here. Then it goes up to 100. You know what I'm talking about, guys. Okay? So in order for that to look like that, that frequency had to be doing that over time. So for it to be in such a precise manner there, and again, if this was a tool flaw, this would have continued over here and here, and it didn't. Okay, you can see it's back here too. So this is, and then you look over here, guys. This is just strange. Okay, why are we getting these Schumann frequencies at different hertz levels very consistently, and then they're even able to have them have a slant? I mean, that takes some crazy manipulation there, is what I'm trying to say. I mean, it's doing it here. So again, guys, I don't know what this is, but I can say that is not normal. Now, something else I kind of put together in my head here, that this might be what's going on. Now, we have this signature that we've been talking about, right, guys? The code thing I just mentioned a minute ago. How we got little, half dash lines. Longer, shorter, kind of looks like Morse code, right? Well, what if that has now come to the forefront and it doesn't show it unless it's on a spike? Okay? That's what I'm trying to say. Are these two things related? The little dash code and the signatures we're seeing here right in our face? I really don't know. But again, guys, anybody has any idea of what this could actually be? And thank you guys for putting your thoughts on that in the comment section, because I have been running down some of that stuff, trying to see if I can actually figure out exactly what's going on here. We may never figure it out, guys. Obviously, we can all theorize and have our own, opinion or whatever on this. But I guess what I'm saying here, guys, is if this thing is actually something we should be paying attention to, it most definitely is migrating towards our base frequency. All right, guys, I think, I'm just going to go ahead and end it there. I'll try to come back with some more updates. We got magnetosphere hits also to talk about, directional, all kinds of crazy stuff going on. Volcanoes, guys, pay attention, pray for those people. There was just another one that happened. It wasn't even in the Philippines. This was in, I think it was Ecuador. But yeah, it's just that when we start seeing multiple volcanoes popping off, it's time to pay attention. Okay, not that, volcanoes always are erupting every day, all day. Okay, but not like this. Especially the Scott did a live stream yesterday, and he was showing the cloud, the volcanic ash cloud off the top of that eruption, and it had so much volcanic lightning, it was ridiculous. Okay, now volcanic lightning isn't typically what we think of as lightning. It looks like it, but it's not caused by the same stuff. Okay, there's a lot of friction, a lot of heat involved there in order for that to actually happen. There's some science behind it, but it is true lightning. So, but anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.